Hello everyone, I'm Shreya from Sri Venkateshwara College of Engineering, studying in second sem Department of Electronics and Communication. Now, I'm going to discuss about a topic of basic electronics, that is, op-amp parameters. In that, the first one is gain. The gain of an operational amplifier op-amp is the amplifier factor between the two input and output voltages. It represents how much the op-amp amplifies the input voltage. The gain is typically expressed in decibels or as a ratio. The voltage gain of amplifier is defined as voltage gain is equals to output voltage by differential input voltage. Here, output voltage we denoted as VO and differential input voltage as VID and voltage gain as A. So this is the equation of voltage gain of amplifier. And the second one is input resistance. The input resistance of an op-amp refers to the resistance seen by the input signal. It is a measure of how much the op-amp circuitry loads the input signal source. For the 741C, input resistance is a relative high 2 MQ. For FET op-amp, this value is amazingly large. And the third one is output resistance. The output resistance of an op-amp refers to the resistance seen by load connected to its output. It determines the ability of op-amp to drive a load without significant signal loss. A lower output resistance helps maintain signal integrity and reduces voltage drops. CMRR, that is common mode rejection ratio. Common mode rejection ratio is a measure of an op-amp's ability to reject common mode signals. Signals present on both input terminals. It quantifies how well the op-amp amplifies the differential input signal while rejecting common mode noise. CMRR is defined as a ratio of differential voltage gain AD to common mode voltage gain ACM. That is, CMRR is equals to AD by ACM. And the fifth one is slew rate. Slew rate or SR is a maximum rate of change of output per unit of time and is expressed in volts per microsecond. It defines how quickly the op-amp can respond to change in the input signal. That is, SR is equals to dV0 by dt. The slew rate changes with change in voltage gain and is normally specified at unity plus 1 gain. Bandwidth. Bandwidth of an op-amp refers to the range of frequencies over which the op-amp can accurately amplify signals. It is usually specified as the frequency at which the gain drops by a certain amount, such as 3 decibels. The gain bandwidth product is the bandwidth of op-amp when the voltage gain is 1. And the seventh one is input offset voltage. Input offset voltage is a small voltage difference required between the input terminals of an op-amp to bring the output voltage to zero. It is an inherent parameter of op-amp and can introduce errors in precision application. The input offset voltage is typically specified in millivolts. And the eighth one is input bias current. Input bias current is the current that flows into the input terminals of an op-amp. It is an important parameter to consider when designing circuits that have high input impedance. Input bias circuit, that is IB, is the average of current that flow into the inverting and non-inverting input terminals of the op-amp in the equation form. IB is equals to IB1 plus IB2 divided by 2. And the ninth one is input offset current. Input offset current is the difference in the bias current flowing into the two input terminals of an op-amp. The algebraic difference between the current into inverting and non-inverting terminals is IIO is equals to IB1 minus IB2. Input offset current. IIO in the form of an equation. And the 10th one is the ideal op-amp. An ideal op-amp would exhibit the following electrical characters. Infinite voltage gain A, infinite input resistance Ri so that any signal source can drive it and there is no loading of preceding stage. Zero output resistance RO so that output can drive an infinite number of other devices. Zero output voltage when input voltage is zero. And the 11th one is equivalent circuit of op-amp. Figure shows an equivalent circuit of an op-amp. This circuit indicates important values from the data sheet A, Ri, and Ro. AVID is an equivalent voltage source and RO is the equivalent resistance. Looking back into the output terminals of an op-amp. And the 12th one is open loop op-amp configuration. In the case of amplifiers, the term open loop indicates that no connection either direct or via another network exists between the output and input terminals. The output is not fed back in any form of the part of signal input. The output is not fed back in any form of a part of input signal and loop that would have been formed with feedback is open. There are three open loop op-amp configurations. They are differential amplifier, inverting amplifier, non-inverting amplifier. Now we'll discuss about differential amplifier. Differential amplifier, in which input signal V in 1 and V in 2 are applied to positive and negative input terminals. It amplifies both AC and DC input signals. This means that V in 1 and V in 2 could be either AC or DC voltages. Voltage drop across these resistors can be assumed to be 0, which implies V1 is equals to V in 1 and V2 is equals to V in 2. And finally, V0 is equals to AV in 1 minus V in 2. Gain A is called commonly referred to as open loop gain. And the second one is the inverting amplifier. In the inverting amplifier, only one input is applied and that is to inverting input terminal. The non-inverting input terminal is grounded since V1 is equals to 0 voltage and V2 is equals to V in. From equation before, V0 is equals to minus a V in. The negative sign indicates that the output voltage is out of phase with respect to input by 180 degree or is of opposite to the polarity. The last one is the non-inverting amplifier. In this configuration, the input is applied to non-inverting input terminal and the inverting terminal is connected to ground. V1 is equals to V in and V2 is equals to 0 V. Therefore, according to the equation, V0 is equals to AV in. This means output voltage is larger than the input voltage by gain A and is in phase with the input signal. Thank you.